For the second type of question in hypothesis testing, we have that the question gives you the conclusion of the test. So he tells you whether the test is accepts the claim or rejects the claim. Okay, but what we don't know is one of the parameters. So it can be your population mean, it can be your population variance. Okay, so in this question, we have that the number of samples that we use to conduct the test is unknown to us. Okay, so let's read the question first. So we have that John's favorite drink is a bottled carbonated soft drink from company A. After years of drinking, he thinks that the volume of soft drink in a bottle is less than what the company claims to be. Okay, because of all the bubbles. Kind of makes sense, right? Because if you let out the bubble, maybe the volume is lesser. So he decides to conduct a hypothesis testing to test the claim. So the population mean, okay, this is important, so let me highlight. The population mean, okay, is 330. The population variance is 25 milliliters square. Okay, the conclusion of the test at 5% significance level. Okay, let me highlight the 5% or so. Okay, so at 5% significance level, okay, there is insufficient evidence. Okay, to conclude that the volume is less than 330. Okay, that means we can't really tell whether the company is saying the truth or not. Okay, something like that. Okay, so during the test, somehow he forgot the number of bottles, okay, that he used during the test. Okay, all he remembers is that the average volume, okay, let me highlight again. The average volume of the bottles is 329. Okay, and we are supposed to find the range of the number of bottles he used during the test. Okay, so as always, I would like to write down, okay, in two categories. Okay, one is your assumption, one is your challenge. Okay, so assumption, you can think of it as your null hypothesis. Okay, so our notation is H0. Challenge is your alternative hypothesis. Okay, the notation is H1. Okay, so in this case, your null hypothesis is that we are supposed to assume that the company is claiming the right thing. So we say that the mean is what the company claims, 330 milliliters. Okay, so H1, the alternative, is what John thinks. So he thinks that the mean is actually less than 330 because of the bubbles. Alright, and we are supposed to test at 5% significance level. Alright, so that's our step 1. Step 2, I would like to write down my distribution. Okay, so I'll let X be a random variable representing the volume of soft drink in a bottle. Okay, so what we know about X, okay, from the question is the population mean and the population variance, right? The population mean is 330, population variance is 25. So if I write down these two information, so I can say that the expectation of X is 330, the variance of X is 25. Alright, and then let's go the theoretical way first. That means if I were to conduct my experiment repeatedly, right? So let n be the number of bottles. Okay, bottles John used. Okay, that means we repeated n times, right? So theoretically, if I use n bottles, then the average of n bottles I will denote it by a x bar. So it is supposed to be a distribution, right? Because theoretically, we don't know what's the exact volume of each bottle. We only know the behavior. Okay, there's some kind of distribution. So we define this to be x1 plus until xn divided by n. Okay, for this example, let's assume that n is sufficiently large. So we can assume that it is a normal distribution by CLT. Okay, it's a approximation. The mean will be 330. Okay, the same as the single variable version. The variance, if you recall from the previous video, I can simply divide by n. Okay, the number of times I repeat the experiment. Alright, so this is my theoretical distribution. This is how my result should behave, okay, according to this normal distribution. Alright, then the next thing that I know, okay, from the actual experiment that John conducted, okay, the average volume of those bottles is 329. Okay, so mathematically, we denote it as a little x bar is 329 milliliters. Alright. So up to this point, okay, I would like to draw the distribution of x bar first, okay, to understand how things are, okay, and to understand if we were to reject or not reject, what are we supposed to conclude, right? So let me sketch first. Okay. So you have a bell curve. Okay, your mean is 330. And this is supposed to be a left tail test, right? Because the alternative hypothesis is less than. Okay, so less than. So let's denote this as your critical region. It's your 5%. Okay, and because the question says that we do not have sufficient evidence to reject the claim, so what I can say is that my x bar, okay, it must be somewhere here, x bar. Okay, so the 329 must be somewhere in this region. Alright, so what can we do to find the value of n now? Okay, typically, most teacher will say that you just convert it to your standard normal distribution, okay, which is what I'm going to do here. Let's see how we're going to do that. So when I convert to my standard normal distribution, two things I'm interested in is my critical region, okay, and this x bar here. Okay, let me work with x bar. When I convert to my standard normal distribution, okay, what I need to do is to take x bar minus mu over the square root, the standard deviation, which is square root 25 over n. Okay, so usually we call this our test statistics. So this is your test statistics. Okay, I'm just going to call this short form TS. Okay, your test statistics. By formula, it is supposed to be 329, as in if I just sub in the values. Minus 330 divided by, this will be 5 over square root n. Okay, I will just leave it like that now. So I know that this point, if I were to sketch the standard normal distribution now, Z, okay, I know that 330, okay, it will become 0 because it's a standard normal distribution, right? And this x bar, it should be roughly somewhere here. Okay, your danger zone should still be around this area here. Okay, this is still 5%. Okay, so our idea now is to find out what is this point here. Okay, this rate point. If I know what is this rate point, then I can easily form an inequality for the test statistics, right? Because I know that the test statistics has to be on the right side of the rate point. So it will be greater than whatever this rate point is. Okay, so how can I find this rate point? Okay, there's a name for this point. It's called your critical value. Okay, it is a point where it marks the start of your critical region, right? So what I can do now is that, because I know that this is a standard normal distribution, so it's just a normal distribution, mean 0, standard deviation 1. Okay, so I can use my GC and type in inverse norm. Okay, input my area, my area in this case is 5%, right? So 0.5, 0.05, 0.1, I think. Okay, let me just use the calculator now. So let me go to inverse norm. So it should be under distribution, I think. Okay, and you go down to inverse norm, that one. Okay, so the area in this case is 0.05. Okay, the mean is 0, the standard deviation is 1. So we can paste, run. Okay, so it tells us that it is negative 1.645. Okay, maybe I take one more decimal, 1.6449. Right. So I know that my critical value is negative 1.6449. Okay, so that helps me form my inequality over here. So I know that my test statistics, because the claim says that, the test says that we are not rejecting because of insufficient evidence. I know that my test statistics is on the right hand side. That's why it's greater than the critical value. So negative 1.6449. Okay, so more or less you can see where this is going. All I need to do now is to manipulate the equation and solve for n. Okay, let me try to do that here. Okay, in blue. So if I were to simplify this inequality, let me see, you will get negative square root n is greater than negative 1.6449 times 5. Let me see. Yeah. Okay. And let me just press my calculator first. So I have 1.6449 times 5 as, okay, that's 8.2. 2245. Okay, so I can solve for n now. I forgot my negative. So my n will be greater than, okay, firstly you can remove the negative sign now. Sorry, I shouldn't. Okay, a very careless mistake. If I want to remove the negative sign, I need to multiply by a negative. So your inequality sign is going to change. It's going to be less than. And then what happens is that I need to square. So when I square this number, 8.225, can I just square like that? Okay, it is 67.64. Okay, 67.64. Alright, so it tells me that the number of samples that I use, it should be less than 67.64. Right? So this is the range of numbers of bottles that John used to get the conclusion that the hypothesis test will not be able to reject the claim because of insufficient evidence. Alright, so hopefully this example here explains the idea. Okay, let me roughly summarize for you. Okay, firstly, write down your H0 and H1 as per normal. Okay, at this point, I prefer to write down a variable X representing the volume of soft drink in a bottle. Okay, write down the information you know. Okay, write down how it should behave if you repeat the experiment n times. Okay, remember this is your theoretical behavior. This is how you should see your result. Okay, it should behave like a normal distribution, mean 330, and variance of this. Alright, then the next thing is write down what is the actual result. Okay, the one that you got from doing the experiment in real life. Okay, from the question it says it's 329. Okay, then I like to sketch my graph. Okay, this is my X bar graph. It should behave like a bell curve here. Okay, I mark out my critical region. Okay, the 5% over here. It's on the left because it's a left tail test, right? Then I know that because we are not going to reject the claim, so my X bar is on the right hand side here. Okay, the green color part here. Okay, so how to use this information to solve for n is that we can convert my graph here, the X bar graph, to a Z bar. The Z graph. So the Z graph is your standard normal graph, which is normal distribution mean 0, standard deviation 1. Okay. The good thing about this standardizing method is that you will be able to find out where is X bar in the Z graph, okay, using this formula over here, this one. Okay, this formula will find the test statistics, which is this point over here, your test statistics. And we will be able to form an inequality by comparing with the critical value. Okay, this weight point here. How do we find a critical value? You just input into your calculator inverse norm. Okay, because we know the area is 5%. So we inverse norm to find what is the point. Okay, it says that it's negative 1.6449. Okay, it forms you your inequality. From there, it is just solving a simple algebraic inequality. So that one, I believe you should be able to do it. Okay, then you get your answer. Okay, so in general, for all the questions where you have an unknown in your parameter, this is what we'll do. We'll standardize the graph. We compare to the critical value to form an inequality, or simply an equal sign is also possible. Okay, and then we can solve for the unknown. All right. So see you in the next video.